Welcome to our YouTube channel students, e-learning hub by Udgam Welfare Foundation. Here we provide the best content to our students, and what we provide here basically we provide the video lectures, e-notes, online test, which is very important in our video series here. No one else is providing you this. This is our online test, and this you are going to get on our website, which is udgamwelfarefoundation.com, and we are going to provide the topic wise test that will be very beneficial for you to enhance your mathematical skills. In this video series we are going to discuss about the number system for grade 9 students. So let's get started. Let's first understand the concept of number system. In number system we have natural number. First one is natural numbers. So natural numbers are those numbers which start with 1, 2, 3, 4 and so on. If we represent this on the number line, then we can write it this way. This is our 0, and towards the left side it will be our negative numbers, and from here this is 1, 2, 3, 4, 5 and so on. This is 1, 2, 3, 4, 5. So this is the representation of natural numbers on the number line. Very simple. Now let's understand about the whole number. Whole numbers. Whole numbers are those numbers which include the natural number and 0 as well. So if we represent this on the number line, then we are going to represent this way: 0, 1, 2, 3, 1, 2, 3, 4 and so on. So we have 0 as well as all natural numbers here. So whole number is basically bigger, you can say, than natural numbers. So if we represent it in the form of a diagram, then we can say that this is the natural number and this is our whole numbers. Very simple. Now let's understand about integers. So what are integers? Integers are those numbers which include our positive side of the number line as well as the negative side of the number line, like this: 0, 1, 2, 3 and so on. This is our positive infinity and this is our negative infinity, and this is -1, -2, -3 and so on. So this entire number line, which include 1, 2, 3, 4 and negative of 1, 2, 3, 4 as well, it is called the set of integers. Integers are basically represented by Z. Now let's understand the concept of rational numbers. So rational numbers. Rational numbers are those numbers which can be represented in the form of P upon Q, like 2, 1 by 2, 1 by 3, 3 by 2 and so on. Such numbers are called rational numbers. 2 can also be written as 2 upon 1. Very simple. So such type of numbers which can be represented in the form of P upon Q are called rational numbers. Now let's understand what is irrational numbers. Irrational numbers. Irrational numbers are those numbers which cannot be represented in the form of P upon Q. Irrational numbers cannot be represented in the form of P upon Q, like √2, √3 and pi, etc. If you know how to find the value of √2, that is good, because such numbers are non-repeating and non-terminating. That means if you find the value of √2, let's understand and learn how to find the value of root 2. First write 2 here, then divide this 2 with the nearest number as we do in case of division. What number we are going to write here? We have to write the same number here, like 1 ones are 1. If we write here 2, then we have to write 2 here, but 2 twos is 4, which is 4 is what? 4 is greater than 2, so this won't work here. So let's erase it. Similarly, this. So we have to write a number which will bring after multiplication of the same number, like 1 ones are 1. It is closer to 2 but less than 2, right? So we have to subtract here. 2 minus 1 is 1. After that, what we have to do? We have to write 00 here, right? Once we write 00 here, we need to put a decimal here. After that, what we have to do? We have to double this number, that is double of 1 is 2. We have to write 2 here, right? Now the number which we have to write here, let us say we have to write 2 here, and the same number should be written here. For example, let us say 3, we need to write 3 here, right? Now we need to multiply this 3 with 23. So we will get what? 3 3 is a 9 and 3 2 is a 6, 69. But 69 is far less than 100. So we have to increase this number so that we will come closer to 100 here, right? Very simple. Now what we can do here? We have to write some other number. Let's try some other number here. Let's write 2 here again. Now if we write 4 here, then we have to write 4 here, then 4 4 is 16, 4 2 is 8 and 1 9, 96. 96 is very close. 100 minus 96 is 4 here. Now again we need to write 00 here. Let's write this here, 400, right? 400 here. Now again what we have to do? We have to double 1.4. So double of 1.4 is nothing but 28. We need not to write the decimal here. 14, double of 14 is 28. Now again we have to write some number here so that the same number multiplication with this particular entire number will be very closer or less than this 400. So if we write 3 here, right? If we write 3 here, then it is going to increase here, right? 3 to the 6. So we have to reduce it. So let's write 2 here, not 2 here again. 2 to the 4, 8 to the 16, 2 to the 4 1, 8 to the 16 and 2 to the 4 1 5. Again this is higher than which one? 400. So we need to reduce this number again, right? So we have to write 1 here. Very simple, right? 1 here. So here we are getting 281. 10 minus 1 is 9, 9 minus 8 is 1, 3 minus 2 is 1, right? So 119 is here. Now again what we have to do? We have to simply double this number again, right? Simply double this. Let's make some space here. So we can simply double this number here. So double of 1.41 is what? 282. Very simple, right? Now we have to write 00 here. Again we have to write one number and the same number should be written here so that the multiplication of this number and this entire number should be equal to closer to this particular number but not greater than. So if we write 4 here, then we will get 4 4 16, 4 to the 8 1 9, 8 4 is 32, 32, 2 carry 3, 4 to the 8 and 3 11. So it is 11 to 96, which is closer but less than this number. So 10 minus 6 is 4, 9 minus 9 is 0, 8 minus 2 is 6. So 604 is there. Now again if we have to write 00 here, then double of this number is again 4 to the 8, 2 ones are 2, 4 to the 8, 2 ones are 2, 2 8 22. Now again we need to write one number here so that the product of this number and this entire number should be less than or equal to this number if possible. Okay, so the number which we need to write here, let us say if we write 3 here, okay, 3 to the 6, so it seems that it is greater than this number, so we need to write 2 here. So let's write with 2 to the 4, 2 to the 4, 2 to the 4, 28, 2 the is 56. So this is closer and less than 60,000 here, right? So in this manner we can continue this. And how we can prove now that root 2 is an irrational number? Because if we see, all these number after decimal are non-repeating. That means 4 is here, then again 1, then 4, then again 2. Now next number is unpredictable here. In this manner we can say that root 2 is an irrational number, or if we define an irrational number, that means a number which is non-repeating and non-terminating. That means it is not going to cancel here. That means this here we are going to get the remainder always. We are not going to get the remainder 0 at any point of time. So such numbers are called irrational numbers. Now I think this concept is clear. Now let's move towards the real number concept. What is real numbers? So real numbers are those numbers which contain rational, irrational, whole number, natural number, integers. That means which contains rational numbers, irrational numbers, whole numbers, integers and irrational numbers are called real numbers. So if we represent this on the number line, then we will get like this way. Let us say we need to write x is greater than 2 and x belongs to real number. So this is basically read as x belongs to, this is belongs to, right? So x belongs to real number. That means we are saying that x should contain the real number, but the condition is x should be greater than 2. So in such a scenario we will write this way: x contains greater than 2. That means 2 is not included. So we'll write this hollow circle type and we will show this on the number line, or we can simply darken this number line and we will show that all the numbers, whether it is 2.1, 2.2, 3.1, 3.2, so every number till infinity is the answer here. So all the real numbers that comes after 2, x is greater than 2, is called the real numbers. So I think the concept of numbers are clear here. Now let's understand it with the help of a diagram. So this is natural number and this is our whole number and this is our integers and these are the rational numbers and this is our irrational numbers and this is our real numbers. This is our real numbers. So larger circle is called real numbers, which contain all the numbers here, that is the natural number, then whole number, then integers or rational numbers, irrational numbers and every numbers like that. So real number are those numbers which contain everything in it. Now let's understand what is non-real numbers. Non-real numbers. Non-real numbers are generally represented by z and is represented as a plus iota b. Here I is imaginary number. I is imaginary numbers that we are going to discuss in our later classes, that means 11th standard. So here you can understand simply like non-real numbers are also called imaginary numbers, and non-real numbers can be represented in the form of a plus iota b, like 2 plus iota 3, like this, right? So what is this basically? Iota is nothing but under root of -1. Any number if you see like this way, minus root 2, minus root 5, so such numbers are called imaginary numbers, as simple as that, right? So this is the concept of imaginary numbers or non-real numbers. Now let's understand the concept of how to insert rational number, how to insert rational numbers between two numbers, right? So let us take a simple example. Let us take 2 and 3 here. We need to insert a rational number between 2 and 3. Very simple. So rational numbers are those numbers which can be represented in the form of p upon q. So simply we can apply this method, a plus b upon 2. Let us say a is our 2 here and b is 3. So 2 plus 3 divided by 2, that is 5 by 2, that is 2.5 we can say. So 2.5 is exactly lying between here. So 2.5 is a number, or we can simply write 5 upon 2, that doesn't matter here, 5 upon 2. So 5 upon 2 is a number which lies between 2 and 3 and which is called a rational number between 2 and 3. As simple as that. Let's understand this with the help of another example. We need to insert, let us say, 5 rational numbers between 2 by 7 and let us say 11 upon 7, right? We have to write 5 rational number between these two numbers. So we can simply see that here the denominator is same. So we can easily write like 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7, like this. So all these numbers lie between 2 by 7 and 11 by 7. And we can simply write 5, 6, 7, 8 numbers between these two numbers, right? Minus 3 upon 14 and 9 upon 14, let us say, right? So here we need to insert, let us say, 20 rational number between these two numbers, with 20 rational numbers. So how we are going to do that? We can simply multiply the numerator and the denominator by 10. Minus 3 by 10 upon 14 into 10. Right, 9 into 10 upon 14 into 10. Okay. Now here we get minus 30 upon 140 and 90 upon 140. Now in between these two numbers, we can easily find n number of rational numbers. So how we are going to insert this? See, minus 30 we can simply write minus 31 upon 140, minus 32 upon 140, minus 33 upon 140. So similarly we can easily insert 20 rational number between these two numbers. Very simple. So this is the basically shortcut or easiest method to insert n number of rational number between any two numbers. Let's understand how to convert a rational number into decimal form. Rational to decimal. So let's take an example of 22 by 7 here. Let's divide 22 by 7. So this is 7 3 is a 21, 1 10, take decimals, 7 is a 7, 3 30, 7 4 is a 28, write 2 here, 20, 7 2 is a 14, 60, 7 8 is a 56, 40, 7 5 is 35. So 40 minus 35 is 5, again 50, 7 7 is 49, again 10, 7 is 7. So it is going to repeat after 7.1427, right? Again it start with 1 and so on. So we can simply write 22 by 7 is equal to 3.142857 bar. Simply, right? So in this manner we can simply convert a rational number into a decimal number. So that's all in this particular video. In our next videos we are going to cover the further concepts on the chapter number system. Till then, goodbye and take care.